Hi, good morning. Welcome. Thanks for deciding to be here. Please feel free to comment and ask questions and to disagree or yeah, it'd be nice to have some good discussion. Thank you to AMA for asking me to consider doing something, presenting something. And so I hope that this session will be worthwhile and that yeah, we can learn from each other in it. So the picture that you got there on the opening screen is of a paper swan that one of my students in my Bible study class actually gave me as a thank you gift. I don't know how long she spent on this. She folded 300 individual pieces of paper, which she then molded and slotted together to form this beautiful paper swan. And it's got nothing to do with the talk that I'm doing this morning, but it just meant the world to me. And I just wanted to share it with you guys that it's just beautiful. It's just the time spent on it was just really special. And yeah, it's amazing. Anyway, so I just wanted to share that with you. Right. So does notation matter? So the first thing that I want to ask you is how well do we define something? How clear are we when we define something? So have a look at this very tongue-in-cheek picture. And I think you get the point. You know, a four-sided side of equal length with four right angles. And annoyingly, that figure covers that whole description. So I'm wondering when we speak in class, and I speak to myself as well in this, how clear are we actually in what we say? And when it comes to notation, how careful are we? This issue of universal notation struck me a couple of years ago. I took a group of primary school students to Hong Kong for a maths competition. And the competition had been scripted in Mandarin, and so it needed translation. So a couple of us were there trying to translate this into English, and we thought that English would be acceptable for if you come from the UK, the Philippines, South Africa, the USA. And then we came across this thing, and I'd like to know if you can write or just maybe unmute yourself and tell me what do you think that means? Now I know there's got to be a context, but on its own, what do you think something like that? What does it mean? If you want to unmute yourself and maybe give me some ideas. There's no right and wrong answers here, by the way.
It feels like that show QI where the obvious answer we're going to get penalized for saying it. A coordinate?
It could be a coordinate, correct? What else could it be?
It could be a decimal in some countries.
It could be what, sorry?
A decimal, 250.101.
Interesting. Okay. What
Could
else?
be a balance sheet. Don't they put numbers in brackets if they're debt?
Okay. Some other things that we use in year 8 and 9 that could mean something else as well. Okay, so looking at just those three answers that we've got, you can see the variety of what that means. So it could be a domain or a range. Okay. Somebody mentioned a coordinate point. And what was interesting, and this was the context, was that it could be a number. But the problem is what number? You see, and that is in this context, that was the problem because the number was given in words and then it was written as a number in brackets. But in America, that means 250,101. In South Africa, it means 250 decimal points 101. And so I don't know if there's any other country in the world that uses a comma instead of a point for a decimal place, but South Africa does. And
Germany does as well.
Where, sorry?
Germany.
Oh, okay.
So European
So
countries.
you see, yes, and South Africa takes its its language and stuff from European origins. So we actually had to design two different translated papers to give people in different contexts. So it struck me from that simple thing that notation is not standardized in maths. So here's another question for you to ponder. And again, it's not meant as a trick question. What operation is implied? So if you want to unmute yourself and answer, that's fine.
Multiply.
Multiply. Oh. And do you think a primary school child understands that?
No.
Because I think it means add. 4.5. Okay, what does this mean?
Yeah, for me,
Multiply.
that's
It's multiply.
That means multiply, right. What does this mean?
I think it's a mixed fraction, adding and division.
So do you think it means, so you're saying adding and then division? Okay. You see, so suddenly the notation is no longer clear, is it? In primary school, 4.5 means 4 plus a half. By the time you get to high school, this could mean 4.5, or it could probably mean in an algebraic context times.
And also, when they go to put it into their calculators, unless they use the mixed number fraction,
Correct.
it is seen as times on their calculators.
Correct. So in other words, it's really important that when kids use a calculator, they use their own calculator and they learn to check their answers. Because often if you type in 4.5, if a child is not thinking, they're going to get 2 out as an answer. Because that is what the calculator is defaulted to do, unless you put it in the mixed fraction mode. So it's really significant that often what is written on paper, as opposed to what is typed into a calculator, is not the same thing.
Mm.
And so now you and I are already debating what this bottom one means. So what do we expect a child to understand by that? And we've got a couple of years head start on a student. Here's another one. I assume we understand that. But I'm not sure that many kids understand that that's actually the same thing.
Mm.
We don't use this version often, but it's not wrong. Okay, we generally put the minus either on top or in the middle, but that is not a wrong version. Here's the confusion.
I'd like to say it is, if we're allowed to, because the number is negative. It's not the top or the bottom that's negative. It's just considered a negative number.
Correct.
And so by rights, the negative should be out front, not associated with the top number or the bottom number.
Okay.
Unless you're
Like so.
talking about a gradient.
Yep, but then you
There you
simplify
go.
it. Then you simplify it, and it just
Yeah.
becomes a negative gradient, not a negative rise or a negative
Yeah.
run.
But they all do. Yeah.
But the idea is it's negative. It doesn't matter in that context. It's just a negative gradient. You can draw it either way.
But it's interesting there because the word that is coming out here often is the word context. So when we teach something, such as gradients, maybe initially we do want to put the plus and the minus wherever. But yes, when they need to simplify the answer. Now, this last version at the bottom here, again, I think it's Tracy who was saying we need to put the negative in front. But So I couldn't get the computer, I couldn't get this typed the way I wanted on the computer. So often when kids write negative a half x, they write negative a half, and then the negative and a half is between the two blue lines on a page, and then the x is written on the bottom blue line. In other words, it's in line with the 2. And the I catches the 2 and the x, rather than what should be the 1 and the x go together. And so I've been trying to drill into my kids that that x must be written in the middle or on top, but to put it at the bottom, while it is technically correct, the visual impact is not promoting the mathematical concept that it is the 1 that is multiplied with the x, not the 2. Okay. So those type of things are all the same, but again, I'm not convinced that our students always understand that. Now, sticking with fractions, I really believe that there is so much importance in terms of teaching and hammering basic junior maths, because it has a knock-on effect in everything. So let's have a look at this thing. Okay, this is now continuing our discussion as to where does the minus belong. Okay, so it means it's the same as that. Okay, it's the same as that. But it's definitely not that. And this idea of putting the negative, applying the negative applies either to the whole of the top, not to select extracts at the top, or it applies to the whole of the bottom, or work out the top, work out the bottom separately, and then negate your answer. But kids so often make that a problem, where they do not understand that this minus refers to both parts of the numerator. By the way, can you see my arrow on the screen, or can you not?
Yes.
You can. Okay, great. So this type of thing now, in terms of solving equations. Now there's many ways in which we can go about this. I try and teach my kids, one of the ways is multiply everything through by the common denominator. Okay, so an equation is a balance between a left-hand and a right-hand side. And as long as what we do on the one side is balanced by what we do on the other side, while we're changing what is on the sides, we're not changing the balance between the sides. So I multiply top and bottom by 6. And now when I simplify those fractions, I make sure that 6 divided by 6 is, note the 1. I want my students to write that 1 in, because that way, hopefully, they will click that that minus 1 is multiplied with both things of what is in the brackets. If we just say 6 divided by 6 and we don't put the 1, again, I think the danger is there that the kid assumes the answer is 0 because they're not seeing anything. But the answer is not 0. There is something. There's a 1. So, yeah, that's the way I approach it. And then hopefully with that bracket and with that 1, hopefully they'll get the +2 and not a -2 and eventually get the answer.
I find another notation that we're losing a lot due to calculators is understanding when to put brackets in. So by rights, that x minus 2 on top of the fraction should have a bracket, because it's the idea it's all of that divided by 6.
Correct.
And you could write that as x divided by 6 minus 2 divided by 6, and they also don't understand that. They often don't relate that.
Yeah. Okay, so now I'm going to stay with fractions, and I'm going to go to probably year 11 work. let's solve that equation, and it can't factorize, so we're going to use the quadratic formula. Now, this is one very popular incorrect version, because that first minus, again, is not in front of the fraction. It applies only to the first term of the fraction. Okay? So, yeah, I think it's really, and I don't know how many times I have my kids don't write the x equals, which annoys me, because then what are you finding? They don't extend the third line. In other words, technically, if the line stops there, the last 2 and the 4 are not under the third sign. They don't write this division quotient thing the whole way through. So, yeah, maybe I'm a bit anal about that, but I do think the way we write it is important. And this is definitely wrong because of the minus, or of where the minus is. But how annoying is this? If I do this properly, I get the same answers. So what are you getting upset about? Look, I got the same answers. The reason you got the same answers is because of this plus and minus. But this first version is actually wrong. So when we do, for instance, level 2 NCEA algebra, if the student writes down the answer, not good enough for us. We want to see the substitution, because maybe they did that. Maybe they just copied it from the neighbor next door. But that is one of the issues. Another issue is, often they don't put this -7 in brackets. But somehow they get the right answer out with mathematical magic. So it is significant that kids record what they are doing when they are using a calculator. Again, I don't know whether the child did that or whether the child did that to get the same answers coming out. So we want to see the substitution that the child does for that. So those are some of my thoughts about fractions. Now, my other pet irritation is I have 3 major issues that I want to discuss. The first one was fractions. Here's the next one, our use of brackets. Now, do you see that the use of brackets on the left is different to the use of brackets on the right? On the left, f minus 3 really means find the value of the expression, find the output of the expression when the input to the expression is -3. That's what the brackets mean. That's not what it means on the right-hand side. On the right-hand side, it means multiply. So that's the first case. Okay, here we're finding inconsistent. Well, I won't say inconsistent. Maybe that's not the right word. But we're finding a different application of the same notation in the same sentence. And fx notation is something which I don't think we actually spend enough time debriefing. We think that the students would pick it up via osmosis somewhere along the line. But what I also realize, I don't know so much about New Zealand, but I know in South Africa, what is drilled in is that, can I pick on somebody here? Let me go. Olive, let me pick on you. I don't know who you are, so I'm going to pick on you. Will you read just the left-hand side? Will you read that for me? How do you read that?
F of -3 is
Yes.
-3 squared
Okay,
minus
so Olive,
-3.
just the very first line, left-hand side. How would you read that?
F of x
equals...
equals...
Okay. Jane, can I pick on you? How would you read that left-hand, that very top corner? How would you read that?
I'd be the same as Olive, f of x.
Exactly. But what does of mean? In primary school, of means multiply. So when our kids get this wrong in high school, when they end up dividing by -3 or whatever, maybe that's why, because f of x is drilled into them. Of in primary school means multiply. So they think f of -3 means whatever f is multiplied by -3. And that is part of the language that we use in mathematics, again, meaning different things in different contexts. So I've now stopped using f of x and I just use fx. Because that word of, if you think of, the little anagram BODMAS, brackets, of, and then division multiplication, that word of, again, is meaning two different things. Now, let me ask you this. Let me ask Felicity here. Felicity, won't you read to me the instruction underneath the graph?
Sketch, I presume it means the graph of f of x is equal to sine x.
Now, would you say f of x equals sine x, or would you say fx equals sine x?
I'd probably say fx. No, I'd say f of x.
Okay, but now you're thinking now, aren't you?
Yeah, I am. You've got me
You see-
thinking.
You see, now again, it's interesting because what I say is sketch the graph of should be sketch the graph of fx equals sine x. There, I don't say the of.
Oh.
And I'm wondering, well, why don't I? Why am I using two different languages for the same notation, fx?
Honestly, I'd probably say the function of x
Okay,
is equal to sine x. I'd probably use the word function in this when
Yeah.
I'm doing it initially.
but either way, we're not using the same language as the previous slide, is it? Where we're using f of x.
Yeah.
So here, again, as math educators with a couple of decades experience behind us, we expect the child to understand different language in different contexts, but the notation stays the same. Okay, so it's something which I've just been aware of, is that, and it's something which I've only recently become aware of in my recent thing, in my education experience. So now here's another issue. Sine 60 is equal to sine 30. So the answer is 2. So what do the kids do? Well, they cancel the signs, and 60 divided by 30 is 2. Because so often, I don't know about you, but I found myself about talking, here is the sine graph. I make no reference to an angle when I say the sine graph. Surely it should be the sine of x graph. Because sine without an angle is a pointless concept. And when you draw pictures of a right angle triangle with the opposite and the hypotenuse, you can't draw a picture of the opposite unless you know where the reference angle is. So kids often, from the way we speak, end up splitting sine from the 60, when actually sine without an angle is a pointless concept.
Do you think that's because they don't understand that sine and 60 are not factors of each other?
Oh, maybe.
So the idea is you can only cancel off factors, and therefore if you put brackets around those because they're not factors, maybe that would get rid of that issue. But I agree, it comes back to fractions. When we're simplifying fractions,
That's right.
the language we should be using,
Yeah.
we can take out a common factor. What are the factors? Because it's the same if you've got x plus 2 over x, and they'll give the answer as 2.
Yeah. Yeah.
But
And it
inserting
also
the
again
brackets,
links with, sorry?
inserting the brackets is going to possibly convey multiplication there, and then they're going to think it's okay again that the 60 and the 30 could cancel down and the signs would.
So this links up again with something we mentioned with reference to fractions, is that the way you write a fraction, and depending on the mode that you write the fraction in a calculator, you could get a different answer. So this now goes to my next bugbear, which is exponents. We use the same -1 notation in the context of exponents and in the context of functions differently. And so often kids think that when they press shift sign -1, they are doing 1 over sine, when actually what they are doing is they're using arcsine. But the annoying thing is, that's all that you can get out of a calculator. This first version, which is the way it's written in most textbooks and the way we write it in most assessments, is the way a calculator cannot type it. If you want sine squared, you need to type it that way. Which is probably a safer way of typing it, but my point is that a calculator cannot type that first version in. And I don't think, many kids understand that the way this is sine squared A, sine A in brackets squared is the same thing. And then, of course, when you come to something such as calculus and you work in radian measurements, now the square refers only to the A. So it's significant, and we need to spend time debunking this type of thing, because I don't think it's obvious to kids. As I say, we've got a couple of decades head start, but they're doing this for the first time. Okay, so the one thing I wanted to look at was fractions. The other thing I wanted to briefly discuss was exponents. And now I want to briefly look at units. So here's an example which I altered slightly from a past level 2 exam paper. A is equal to that, defines the growth of a water pool according to time. Find the rate of change of the area with respect to time after 9.6 seconds. Okay, so this means rate of change means differentiate. And now 2 questions on this. First question is, NCEA and even Cambridge don't mind if you don't put the unit in. But mathematically, what does 5 pi mean? It means maybe it means I'm going around a circle 2.5 times. What does this mean? If we don't put the unit in, we're missing the idea of rate. Furthermore, this notation doesn't help you to understand that you're working with is a rate. It's very convenient, but this notation is better defining you that you are working as a rate. And hence, maybe the unit is significant then. So yes, using y dash or a dash, very convenient. But it's not clearly defining for a student what the rate is. Here's some more examples.
Do you think there's also a lack of understanding? You wrote it back there as square centimetres with a slash minute for per minute, when in actual fact, when we sort of think about it, it's actually minutes on the bottom, so we should be getting into that notation of minutes per to the power of -1, if you're going to write it like that.
Correct. And so do our students understand that the word per means divide? And correct, do they understand that this actually means minutes is at the bottom? But I don't know how many of you will write, how many of your students write fractions where they write them in one line with this thing to indicate the bottom. And it becomes problematic when you have a fraction such as 4.5. So what is, if they're at 4, 1/2. So what does the 2 refer to? The 4 and the 1, or just the 1?
Mm.
But I quite agree. I don't think that they understand that that slash actually means per, which means divide, as in kilometers per hour, or $80 per kilogram. And those again are things which are kind of like, yeah, junior school mathematics. So now taking that further as to what was just discussed, you have no idea how many wrong answers I get to that question. Okay, what does the square refer to? To the 10, the centimeter, or both? And so many people tell you that 10 centimeter squares implies 10 centimeters by 10 centimeters. It doesn't. It probably means 3.1 by 3.1 centimeters. The square refers to the units only.
Mhm.
Now, going back to the idea of calculus, those are one of the exponent laws that we deal with when it comes to subtracting exponents. Or, yeah, we subtract exponents because we're dividing the x's. I never teach shortcuts to exponents in year 8 and 9. Year 9 and 10. I think exponents is a very difficult concept for kids to get. And so I will write this as x over x and show them that one x on top cancels with the x at the bottom. That leaves me with x. I don't teach the shortcut rules because, first of all, it's a shortcut. And secondly, they're going to forget it in any case. So I'd rather teach the concept. But now the question comes, okay, if the square refers only to the unit in this problem, have a look at this one. Okay, so now using calculus, and so I've got 20 centimeters squared per centimeter. And centimeters, that means per means that's exactly what we said. Per is at centimeters and now at the bottom. So does that simplify to centimeters squared divided by centimeters? Does that refer to, does that just become centimeters then? And again,
No, because it's a rate.
say again.
No, because it's a rate.
And correct. And that over there doesn't help the understanding of rate, which is again why I think that is better. Okay, because this is at least showing me I am dividing something. And my answer should be dividing something, including the units. Yeah. This came out of a recent, a couple of years ago, also an NCA level 2 question. And I couldn't understand why some of my students, because I've now drilled units, and then I had this variation on a theme where they now simplify the units. But sir, you told us to simplify the units. Yeah, but maybe that's where we need to speak about rates. Okay, units, here's another one. So I don't know how many of my students, this is also out of a past NCA level 2, 120 liters volume. I don't know how many of my students said the volume is 120, plug it into a graphics calculator, solve for T, and T is 2.95. And they're wrong. Because what caught their eye was volume and 120 liters. But the unit is not liters. The unit is liters per minute, which is a rate. And volume is not a rate. The derivative of volume is a rate. So it's really, I think there really is value in looking at the units. Because if they had looked at the units, hopefully they would have realized that it can't be volume, because volume is liters. It's not liters per minute. When it comes to differential equations, acceleration is 5t, integrate that to get velocity. And so often again, that is taught as a shortcut. Why? Surely maybe that is better to write acceleration as a rate. And then from there, the students can see that we're working with two different values, velocity and time, each of which is integrated. Notice I enjoy putting the coefficient of what is integrated in front of the integral sign. I think it makes what is to be integrated much clearer.
Mhm.
I came across I think it was a level 3 question this last week. It was about the integral of this whole hectic thing is the volume of a sphere from 0 to k. Express this thing in terms of a, b, and k. And they explain to you that a and b are constants. If they are constants, then put them in front. And immediately, the number of variables that you need to work with, specifically what you've got to integrate, becomes much clearer. So we look at coefficients. Okay, so I've just explained that I prefer to put the coefficient of what is integrated in front because I do think that it makes it clear as to what exactly we need to integrate. Let's have a look at this one. So I prefer to write that like so.
Mhm.
And I think that's more or less confusing for students, and then we can take it from there. At the school that I'm at, we've designed our own Year 11 syllabus to try and bridge the gap between the current year level 1 and current level 2. And so we do a little bit more functions work. But then what became evident to me is if you are a student writing Year 11 for the first time, as opposed to a teacher setting your umpteenth Year 11 exam paper, if you ask a child to draw that, hopefully they'll get a line. I'm not sure they often will, because the over 2 they don't understand is a coefficient of a half.
Mhm.
But look how close that is. And remember, you and I in an exam situation, pressure, time, and all the rest, look how close that is to that. Here's another example. Sketch that basic parabola. Okay. How close is that to that exponent? And so these are subtle differences, which I think we as seasoned maths teachers kind of become immune to, and which is why I think it's important for us every now and again to do something brand new for ourselves, to see what it means, to struggle through something before we get it. So the first time, for instance, that I taught scholarship calculus, boy, was that a wake-up call for me as to just how much work is involved. Oh, but then the child has got 5 other subjects that they're doing as well, not just scholarship calculus.
Mhm.
And actually, they do want some time to hold their girlfriend's hand or walk on the beach or, I don't know, listen to music. The first time I taught level 3, yeah, it's a bit of an eye-opener as to just how deep that work actually is and how much work is involved to get the nitty-gritty of an excellence at that level. So maybe it is a good thing for us every now and again to do something brand new, to teach ourselves what it feels like to do something for the first time. So guys, that's what I have to say. I don't know if there's anything else that everyone else wants to say before we close.
Thank you, Carl. I'm going to do the outro in a second, but if you've got questions you either want to voice or want to put into the chat for Carl, you can do that now.
There's one other thing I can maybe mention that I've just thought of through something that was stimulated by a comment which we had, was when it comes to learning multiples and factors in junior maths, what are the factors of 10? So often we teach our kids 1, 2, 5, and 10. I'd rather teach the factors of 10 are 1 and 10, 2 and 5. When it comes to factorizing trinomials, 1, 2, 5, 10 is useless. You need them in pairs. And you need to understand how they relate to in pairs.
Good point. So yeah, feel free to pop some stuff in the chat. If you've got any feedback for Carl, pop it in there. That'd be awesome. I will say that if you do have any suggestions about these sessions, send me an email at that web address. Carl's, actually, I think I can put that in the chat now. Carl's already shared a PDF of his slides, and that's up on our event day, so I'll post on that, so you can get access to that if you want. Thank you so much, Carl. That was great. I love that kind of stuff. I had for a long time I didn't really care about the nitty-gritties of some of the stuff, like how important definitions were and the notations that we use and things like that. But I went to a university course a few years back and started to realize that having the idea of something isn't quite as good as having the formality of knowing exactly what that is, so that when we communicate to each other, we're speaking the same language, we're talking about the same things, and there's less room for things to go wrong. So yeah, that was awesome, and lots of things in there that I hadn't thought about the way that we see multiplication and brackets and things like that. So you might have seen this from the first session. Oh, Carl, you want to say something?
No.
So yeah, we do have this new curriculum, and a couple of us just talking and wanted to say that, yeah, this curriculum is really clear about what we're teaching. There is a little bit of unhappiness around the place about what's gone out of that curriculum at certain places. So we just want to say that you guys are good teachers, and keep helping everyone else be good teachers. If you're doing good stuff, it doesn't mean that this curriculum means you have to stop doing that thing. For instance, the PPDAC cycle is no longer part of our curriculum documents, but it is good teaching practice, so we don't have to drop that. And you guys are doing it today. You're engaging with other educators, and if we keep on doing that, we can make the most out of this thing. You may have seen this in the first session as well. We have our AMA Maths Calc Day is open for registration, so find that on our website. It's not too far away, Monday the 24th. The Stats Teachers Day is a little bit later. It's Friday the 5th over, so that's at University of Auckland, and the first one's at AUT. I won't go too much into the Spotlight series. If you are in Aucklander, have a look out early in the year for the AGM, AMA's AGM, which is towards the middle of term 1. Thank you, everybody. Thank you again, Carl. If you're coming back for more in 10 minutes or so, I'll see you then. Thanks.